Happy day, students. Welcome to the Science Academy group of schools, Pallikaranai, grade 9, subject mathematics, topic the number system. Number system, which is nothing but the mathematical representation or mathematical presentation of numbers. Let us see the different types of number system now. Binary system with base 2 using digits 0 and 1. Octal system with base 8 using digits from 0 to 7. Decimal system with base 10 uses digits 0 to 9, and hexadecimal system with base 16 uses digits from 0 to 9 and alphabets A to F. Binary, octal, hexadecimal system, all these decimal number systems are used in computer languages, different technological endeavors and all. But the decimal system with the base 10 is something we use in our day-to-day life. Anything we have to count, we start with 1, right? So anything to count, anything to record, keep a track of, whatever we have to do, decimal system numbers is what we use. Now let us see in our day-to-day life where all we use numbers. Tell me, how many moons does the planet Earth have? 1, right? How many suns are there in our solar system? Again 1. How many planets are there in our solar system? 8. Do you know what is the height of the Mount Everest? Wow, 8,849 meters. Tallest mountain on the planet, right? What is the highest temperature recorded in Chennai today? 38.4 degrees Celsius. That's a hot day for sure. Do you know how much time does the sunlight take to reach Earth? Yes, 8 minutes, 20 seconds. Now you can see in all walks of life, whatever we do, wherever we go, without numbers, we cannot keep a track of anything, we cannot measure anything. If I ask you, what is your height? You will tell me, ma'am, it's 5 feet 2 inches, ma'am, it's 4 feet 9 inches, ma'am, it's 5 feet 10 inches. So, how long will you take to finish your lunch? Let us say, ma'am, I will take 20 minutes to finish my lunch. What are natural numbers? Natural numbers are nothing but the counting numbers. Just now we have seen, no? To count anything, we said we'll start from 1. So all the counting numbers from 1 to 3 till the infinity, they are called natural numbers. The counting numbers or the natural numbers including 0, they are called whole numbers. Now, if we have to record the temperature in Ladakh, let us say, sometimes the temperature dips down 0, right? Then it will be recorded in negatives. So, these negative numbers, including the whole numbers, are called integers. Let us say your mother has given you an apple and you're not that hungry to finish the whole apple. You will eat only half of it. What is this half? The half is nothing but 1 by 2. 1 by 2 is a fractional number. The fractional numbers, which are both positive and negative, are called rational numbers. So, the natural numbers, including 0, are called whole numbers, including the negative numbers are called integers, including the fractional, negative, both positive, are called rational numbers. Anything else we have to learn in this type of numbers? Let us see. Oh, there is something. Irrational numbers. This is something you haven't heard till now or you haven't learned about till now, right? What are these irrational numbers? While calculating the area or circumference of a circle, you might have come across a term called pi, right? What is this pi? Pi is an irrational number. Again, root over 3. This also, you know, square roots you have done in class 8. You know what is root over square root. So, square root 2, square root 3, any root number which does not give you a perfect number or a whole number after finding out the square root is an irrational number. So, root 2, root 3, root 5, root 7, all these are irrational numbers. All these numbers together, natural, Every natural number is a whole number, every whole number is an integer, every integer is a rational number. And these numbers, rational numbers and the irrational numbers together, they are called real numbers. Again, let us recap what is a rational number. You have learnt in class 8. If there are two integers p and q, where q is not equal to 0 and the number that is written in the form of p by q, this p by q is called a rational number. Let us see some examples here. 3 by 4. 3 by 4 is a rational number because it's written in the form of p by q, where 3 and 4 both are integers. 123 by 99, again the same thing. Minus 47 by 63. Minus 47 is an integer. 63 is a non-zero integer. So minus 47 by 63 is a rational number. So many examples we can give. How to represent these rational numbers on number line? We know that every rational number can be represented on a number line. Every number has a place on the number line, right? So if you take this number line 0, 1, 2, 3, 4 and 0, this side on the negative side we have the negative numbers. If we have to represent, for example, 12 by 5, we will write it as 2 by 5 in the mixed fraction form. We know that 2 by 5 lies between 2 and 3 because two parts, whole parts we want. Again, 2/5 of the next part we want. How will we find 2/5 of this part? We will take this portion between 2 and 3 and we will divide it into 5 equal parts. Why do we have to divide it into 5 equal parts? Because the denominator here is 5. So when you divide it into 5 equal parts, if this is 2, the next one is 2 1 by 5, the next one is 2 2 by 5, 2 3 by 5, 2 4 by 5, and the next one is 2 5 by 5, that is nothing but 3. What do we want here? We want 2 by 5 only. So 2 by 5 is this point that can be represented on the number line. Now let us learn what are irrational numbers. We learned that any number which can be expressed in the form of p by q, where q is not equal to 0, is a rational number. The opposite of that is an irrational number. An irrational number cannot be written in the form of n by d or any alphabets you can take, n by d, where n and d are integers and d is non-zero. What did I say? Any number which cannot be written in the form of n by d, where n and d are integers and d is not equal to 0, all those numbers are called irrational numbers. What are the examples? Earlier we have seen, right? Pi is an example, √3, √5, √3 by 2, √20. All these numbers are irrational numbers. Do you know what is decimal expansion? You have learnt it in the lower classes, but not with the exact terminology. Decimal expansion means writing the given number in the form of decimal form. So if I take 20 by 8, how do I write it? In the decimal form. When I divide 20 with 8, I will get 2.5. So 2.5 is the decimal expansion of the rational number 20 by 8. Let us see 10 by 3. If I divide 10 with 3, what do I get? 3 3s are 9. Again 0. Again 3 3s are 9. So it will keep on going and it will not stop at any point. You can do it all through the day. Still it will not stop. You have to do it tomorrow also. So what is this called? This number wherein the numbers won't stop after the decimal point. These kind of decimal expansions will also be there for some rational numbers. So this scenario where 20 by 8 is equal to 2.5 is called a terminating decimal expansion because the decimal expansion stops at some point. But here it keeps on going like 3.3333 and so on. So it is called a non-terminating repeating decimal expansion. Repeating we can say, or recurring we will say. Repeating, recurring means what? It will keep on coming back, right? Like day after day, Monday after Monday, week after week, it keeps coming, right? That is repeating, recurring. Here also the decimal numbers, they will keep on coming, and that number also will be the same thing, 3.33333. So these kind of numbers are called non-terminating repeating decimal expansion, and this can be written as 3.3 bar. You can see the small bar above the next 3, right? So this is how we can write non-terminating repeating decimal expansions. Now let us see the decimal expansion of irrational numbers. Pi, when you calculate the decimal expansion, it keeps on going. It will not stop at any point. It can be 3.141592655 and you will get it. So on. E, which is nothing but the constant which is used in the physics, E is equal to 2.71828188284 and so on. Root 2 is equal to 1.414213563 and so on. What do you observe when you see these numbers? There is no pattern in the numbers that are followed by the decimal point, right? Everywhere there is no pattern followed. They are coming in random numbers. So what do we observe in this? It can be observed from the above examples that the decimal expansions of irrational numbers are non-terminating and non-recurring. What did we observe in the decimal expansions of rational numbers? We observed that some are terminating, there is no problem with them. Some are non-terminating but repeating or recurring. But here what do we observe? We observe that each decimal expansion, there is no particular pattern followed, no number is being repeated, they are not coming back again. So they don't have any pattern. So these are called non-terminating, non-recurring decimal expansions.